Hello and welcome back. I hope you enjoyed yesterday's lesson on tangent lines with space math. That was so cool. I'm really glad that I got that recorded. So today it's gonna be an easier day. We'll actually get through the whole lesson in like 10 minutes. So today will be really easy. We're going to be working with angles formed by tangents and secants and chords. So we've talked about two different kinds of angles already. We've already talked about central angles and inscribed angles. So let me give you an example of those here. Yeah, this is pretty simple. This would have been our warm-up, but we'll go through it real quick. But if we have, oops, oh, that's nice. All right, so if we have a central angle here of 90 degrees, we call this central angle because it's located in the center of the circle. So if this is 90 degrees, we know the measurement of the arc is also going to be 90 degrees. And then what's the relationship between the measurement of the central angle or the arc and its inscribed angle? So I showed you yesterday with GeoGebra how that's always going to be half. So half of 90 degrees is going to be 45 degrees. And regardless if we move this point anywhere else on the circle, so if I moved it down here and then I move these two along with it, I know isn't GeoGebra a lot nicer to like actually look at, but as I move this here, oops, not that. Just that. Okay, cool. Getting better with the pen. Anyway, as I move that, it's still going to be 45 degrees regardless of where I put it anywhere on the circle here. So central angles are angles formed with the vertex in the center of the circle, and inscribed angles are angles that are formed with the vertex on the circle. And they're always half of the central angle, and we measure the arcs by their central angle. All right, so now we're going to be talking about angles that are formed by secants, tangents, and chords. So when we have two tangents, again, we remember these are tangents because they intersect in only one point. They never enter the circle, and they never have to leave it either. Well, when two tangents intersect outside the circle, which is the only place they can intersect, we can find the measurement of that angle formed by the two tangents by using this formula. Now the formula is pretty simple. It's just the big arc minus the little arc divided by 2. So the big arc, of course, is going to be the one that's furthest away from this angle. So if they tell us that's 240, so the big one's 240, minus the little one, which is going to be the one on the inside. Now to figure out the inside angle, we have to look at the big picture. So the whole thing is 360. So what's left out on the inside is 120. So 360 minus 240 is going to give us 120. So 240 minus 120 is 120, divided by 2 is going to leave us with 60. So this angle here is equal to 60. I updated that. No, I didn't. All right, so now we have angles formed by a secant and a tangent. So this is our secant because it intersects a circle twice, and this is our tangent that intersects in one place. So we have 70 degrees of this arc here of the 360 of the circle that's not being used, that's not on the inside of this angle. So when we use our big and little, it's no longer going to add up to 360. We're only going to use the 180 for the big, and the little is going to be what's left over. So add these two together gives us 250, and subtract, that gives us 110. So 180 minus a little of 110 divided by 2. So it's the same formula as when we had two tangents, still big minus little divided by 2. Big minus little divided by 2. We just have the 70 degrees that are not being used in the formula. So the difference between that's going to be 70. When we subtract that, that leaves us with 35. All right, so this angle here would be 35 degrees. I don't know when I started doing that, but it'll show up eventually. All right, now we have the angle here, which is formed by, again, a tangent and a secant. Now this one, they don't tell us what the big side is over here. We do have the little, so we can go ahead and fill that in the formula. But we can't have two variables here with the x and the missing big angle, right? So how are we going to figure out what the big arc is? So look carefully at the diagram and see if there's any clues. One thing you might notice is that this chord here actually goes through the center. So this secant line goes through the center, which is actually a diameter, meaning it gives us a semicircle. So it's 180 degrees up top, and meaning it's also going to be 180 degrees on the bottom. So 180 minus 50 is going to leave us with 130 degrees on this side. So our big angle is 130. Now when we put it in the formula, 130 minus 50 is 80, divided by 2 is going to leave us with 40. So this angle here is 40. All right, secant angles formed by two secants. So now notice there's two parts of the arc that are not being used at all. So we kind of really, they have to give it to us, otherwise there's really no other way to solve it. But we have 150 minus 60. So we have our big minus the little divided by 2. So when we subtract those two, that's going to leave us with 90. Half of 90 is 45 degrees. So still haven't updated that, but that's okay. All right, this one, our big angle, again, we have a diameter, so always be looking out for that, is going to be 180 degrees. Apparently those weren't linked together. 180 degrees. And then on the inside, these three angles, these three expressions in terms of y, 2y, 3y, and y, have to add up to 180 as well. So we can set up an equation adding those together. Leaves us with 6y plus 180, because 2y plus 3y plus 1 more is 6y. So 6y is equal to 180. When we divide by 6, we get y has to be equal to 30. So I'm just going to move that out of the way. So when I plug that back in, 3y, 3 times 30 is going to give me, it's going to give me 90. So I could have used that in the formula, but we don't need that. All right, so we have 90 is our little angle over here. So 180 minus 90, which is 90, divided by 2 is going to leave us with 45 degrees. So this angle here is 45 degrees. All right, the other thing else we could have is intersecting chords. So here we have two chords that intersect on the inside of the circle. Now this one, these chords are special because they're diameters, right? They go through the center. And so if the measurement of this arc is 75, we know that the central angle is also 75. So the vertical angle here is 75, and then the other one, I think there's, yeah, I'm missing one. I remember that now. Then that means that this one is also 75. So it's kind of like a chain reaction. That's special when you have two diameters that go through the center. But what happens when they don't intersect in the center? So right now it's the same angle, 75 and 75, but what if I move it off the center? Well, what happened to the arc up top, and what happened to the arc on the bottom? Well, clearly the one on the bottom got bigger and the one on the top got smaller. Well, how much smaller? Let's say it went to 50. So it went from 75 to 50. So it's 25 less than it used to be. Well, then what's going to happen down here? You might be thinking, where did that 25 go to? Well, the 25 degrees that got cut off here got traded and moved down here. So there's 25 extra degrees of the central of the arc here, which is going to give us 100. So what's going on here? And what's interesting is that's true no matter where I move this, but when that special case of that's 50, this one would be 100. So if I went even further, maybe made that 40, this one would now be 110. So what's happening here? Well, what's happening is that we're actually taking the average. So we're adding the two arcs here. So whether one's a big one or a little one, doesn't matter. We add them together and then we divide it by 2, which is the average. We do that quite a bit in statistics, where we add things together and divide by the number of things. So whenever we have intersecting chords on the inside of the triangle, of course, or the circle, we know that the opposite arcs, or the big and the little one, are going to be the average. All right, so properties of non-central angles. Here we have 50 and 50. Central angles, so both of these would be 50. But as we move them around, what does that tell us about these other two arcs? Well, when we start out in the center, they had to both be 50 degrees, so they added up to 100. But as I move it off center, this one shrank, this one grew. We know the average still has to be 50. They still average to 50, so whatever they are, this one plus this one has to add up to 100. Well, no matter where I move it, it's still, this arc plus this arc still adds up to 100, which is kind of cool. Move it way over here, this one plus this one, still 100. Kind of make it even in the middle. That one plus that one still equals 100, which is interesting because that means that these two, if it was along this like diameter here and I just went like directly sideways, then at all times those two are always going to be 50 degrees, even though they're not central angles, because it's splitting the 100 in half. Isn't that cool? So as you watch that, this angle, that arc there on the top and the arc on the bottom are always going to be 50 degrees. It's pretty cool. Anyway. All right, so get out your homework and we'll go through some of those together. The lesson there, that was 9.5 minutes. So we are flying through this stuff. Really easy day today. So we have a little bit of extra time and probably get through the assignment really quickly. If you want to go back and you missed the NASA math, the space math video from yesterday, I highly recommend it. It was so cool. I liked having a long form video because I could get all of the thoughts and didn't have to rush through it. I usually do that on a Wednesday and it's just way too fast. So I think the video is a really good format for you. All right, so on this one, number 1, we have two non-central angles from intersecting chords, meaning x is going to be the average of those two. Now, if this was in the center, then those two angles would be the same, and the x would be the same as well. But since they're not, it's not going to be 116, and it's not 70. It's the average of those two. So all we have to do is plug it in the calculator and find the average. So I'm going to clear this stuff out. So we have 116 plus 70. And then we're going to divide that by 2, which leaves us with 93. So x is going to be equal to 93 degrees. Number 3, we have 139, 40, and x. Do you notice anything different about this problem? Okay, so the 139 is not actually the angle that's in between those two. So what we would need to do is find the supplement of it. So if this is 139, the supplement of 139 is going to be 41. Now we can use our formula. So we actually don't even use the 139 except to find the 41. Well, if 41 is the average of 40 and x, you can set up an equation to solve for it, but think about it. If 41 is halfway between 40 and what other number? So if 41 is 1 bigger than 40, then what's this one over here going to be? It's kind of a pattern, right? So 40, 41, 42. Yeah, exactly. So if you can start thinking about averages in that sense, like whatever's on one side of the average has to be the same on the other side of the average because it balances each other out, just like a balancing beam, which is totally a statistics concept, which is kind of fun. All right, number 4. Here we have two intersecting segments or secants. So we do the big minus the little divided by 2. So that's going to be 90 minus 20 divided by 2. Subtracting those two gives us 70. Half of 70 is 35 degrees. That was fast. Same thing here. We're not going to be using the 95 except to solve for the x. So if I do this originally, I would have two variables, right? So I got x minus 72 divided by 2, and I can't solve for x and y at the same time. So the first thing I have to do is solve for x. Well, if you look at the whole big picture, the big circle is 360, right? So add those two together and subtract it from 360. So I'm going to do 95 plus 72, okay, and I'm going to subtract that from 360, which is going to leave me with 193. So x is equal to 193. Now that I have my big angle, I can put it here. So big minus little divided by 2. I'm going to go right back to the calculator. So we got 193, okay. 193 minus the inside angle 72, and then I'm going to divide that by 2, which leaves me with 60.5. So y is going to be equal to 60.5. I don't think I did that one, but that is your answer. All right, 17. This is a good one. So on this one, we have two tangents. And when we have two tangents, we know the whole circle is being used. So the whole thing is going to add up to 360. If this is 232, that's my dyslexia in full display. So wow, I really want to say 323. 232, that is really tricky for me, minus the little angle, but we don't know what the little one is yet, but they add up to 18 or 360, so we can put that in the calculator. So 360 minus 232, I really don't like that number, is 128. Okay, so big minus little divided by 2, so we'll do 232 minus 128. And then we're going to divide that by 2, which leaves us with 52. So z is equal to 52 degrees. So inconsistent. All right, 21. So on this one, you didn't see anything. All right, so on this one, so this is probably one of the trickiest ones we have. We have our little angle, so we can go ahead and fill that in. We have 38, so we know 38 is equal to something minus the little angle divided by 2. Well, on this one, the whole thing is 360. I kind of ruined the surprise, but the whole thing's 360. And then if we subtract 140 from it, we're left with 220, right? So 360 minus 140 is going to give us 220. So that tells us these two angles add up to 220. Well, we don't know what x is, but we can write an expression for this one, and it's going to be 220 minus x, right? Because whatever x is, it's just going to be, this red arc is going to be 220 minus whatever the value of x is. So kind of color coding and makes it easy to see what's going on, which is pretty cool. If only I left it as a surprise. All right, so on this one, this is still going to be our big angle. So I'm going to move this whole expression for a big angle. You see how this is kind of a tricky one? I wonder if I can move that one down. Okay, there we go. All right, so it's a little different because we have our angle here that we're not solving for it anymore, and we have two x's here. Okay, so first thing I might want to do is move the 2 to the other side. Now, I can do that by multiplying both sides by 2. I know it looks like I'm doing some really tricky stuff, but all I'm going to do is multiply both sides by 2. So if I multiply this side by 2, I also multiply that side by 2, and then when we those two are going to reduce to 1, so pretty good. All right, so we're left with 72 is equal to the sum of those two, or sorry, 76 is equal to 220, and I can go ahead and add these negative x's. So minus x minus another x is minus 2x. So all I want to do now is add 220 to both sides, or subtract that. So yeah, I'll subtract 220. We'll just deal with negative numbers. Get over it. All right, so what is 76 minus 220? I'm going to do 76 minus 220. It's going to give me a negative number. So that means negative 2x, because those two added to 0. So negative 2x is going to be equal to negative 144. So divide both sides by negative 2. So that value we're going to do divided by negative 2, which is going to leave me with 72. So x is equal to 72. Getting better with this pen. Okay, cool. So definitely the hardest one we did. So if this was 72, then we can actually solve for this. So what's 220 minus 72? It's not one of the answers you have to solve for, but you can now figure out what all the angles are at this point. All right, so I think that's the last one. Yep, that's what I'm going to leave you with. Wow, we did that in 17 minutes. So happy Thursday to you. Spend the extra time, go back, make sure you're caught up on the videos and have all of your homework done. Tomorrow will be our last lesson for the week. Tomorrow is Friday. So tomorrow we're going to do a very similar and simple thing, just dealing with segments instead of angles that are formed inside a circle. So segments formed by chords, by secants, and tangents. So there's just a few more formulas that we need to know. I'm also going to upload a formula sheet with, there'll be formulas on the assignment, but also upload a formula sheet as a PDF that we'll be using for this circle unit. So I'll get that out to you. I hope you guys have a good day, and I'll see you later.